Welcome to my next video. Today we shall be looking at some very important concept in deep learning stroke machine learning. And the concept is the concept of how, when we talk about parameter learning, how parameters are learned. So I want to talk about parameter learning. You see this concept throughout deep learning and machine learning at a basic level and at a neural network level, up to deep neural network, up to recurrent neural network, up to complex tasks like computer vision, like speech recognition, machine translation. You see all these often and often in this concept. It's all about parameter learning. So I'm introducing that important concept with just a basic example in this place. Here I have a sample data of X and Y. Uh, we have X as our input. X can be seen as our input, and Y can be seen as our output. So I have my input to be X and the Y to be my output. So in many cases, we know we know X. In many cases, we know X. Our X is more or less our data point. So we know the values of our X, and what we want to do is to predict our Y, to learn our Y. As a foundational concept of machine learning and deep learning is to use a historical data, to be able to learn what we call an hypothesis function. We learn an hypothesis function so that we can use the hypothesis function to uh, predict future values. Now, I'll quickly say something about the hypothesis function. We have what we call the exact function, and we have an hypothesis function. When we know the exact function, then there's no need for us to use machine learning concept, because we can just write a program that will give us whatever y values that we need to predict, and I'm going to explain that in the seconds. But because we don't know the exact function, we go for the hypothesis function. That is, we are approximating. We don't know the exact. We are approximating. We are assuming. We are trying to learn a function that assumes the exact function, which may not be the exact function in most cases. So for instance, if you look at this sample data, here I have just 4 instances of the sample data. Each row is an instance, what you call a data instance or data sample. So I have just 4 given to us. And you can see the continuous dots means that these sample instances can continue like that, even up to 1 billion samples. So we're just given the first 4 instances, and this is constitutes to our historical data. Now we need to now use this historical data to learn a mapping of what the values of y will be in the future. And this will only work if actually there is a pattern in our historical data. So as you can see here, you will see in this place that we have, if you look at this place very well, when x is 1, y equals to 4, that tells us something, that our when x is 2, y equals to 6. If you look closely at this, a savvy person will be able to predict that the function here, the function f of x here, which is our y, is equals to 2x plus 2. So that means for us to be able to get our y, remember our y is equals to f of x. So in order to learn this function f that takes in x, once we know this representation, this is the equation of this function. So as far as this historical data is concerned, so this is the function that we are trying to learn. So as it were, this is our hypothesis function that we are trying to learn. But it's easier for us to look through this in small samples of data and be able to figure out what this function is. And if we test this function with what you have in the training data, you will see that when x is 4, we have 4 times 2, 8, and plus 2, we get 10. So that tells us that this is the exact function. And coming to the parameters learning, now x is fixed, it's given to us. X is our input variable. Now what are the parameters that we're trying to learn? The parameters that we are trying to learn is these two and these two. So these two constitute to the parameters that we are trying to learn. Let's say somebody who just didn't take time and tried to figure out, and let me call it y prime, and decide that his own y prime, which is f prime x, and says that that is equals to 2x plus 1.9. Now, the person actually has done some good job too in giving us an hypothesis function, which if we use in this case will give us roughly the same thing as this. Now, this is an hypothesized function and this is the exact function. This gives us the exact function based on this data. I hope that gives us a little intuition into what we mean by parameters, and we continue from there next time to let us know that these parameters is what is often being called theta or W. We often use W, or we use the theta symbol for those parameters. Thank you very much, and do let us know your comments about it, and see you in the next video.